There is a cave on the southern tip of Europe where the rock remembers something science spent 100 years trying to forget. For most of the 20th century, if you wanted to describe humanity's closest relative, you reached for the same handful of words. Brutish, slow, instinct-driven, a dead branch on the family tree, replaced because it simply couldn't keep up. That was the story told in classrooms, in museum placards, in documentaries narrated with a tone of quiet pity. Modern humans arrived, and the Neanderthals, intellectually outmatched, faded into extinction like a candle running out of wax. Then archaeologists went back into the caves, and the rock started talking. On the eastern face of the Rock of Gibraltar, a network of sea caves has been under careful excavation for decades. Gorham's Cave and its neighbors sit at the very edge of the continent, a place where, tens of thousands of years ago, the coastline looked nothing like it does today. Sea levels were lower. A wide plain of dunes, marshland, and woodlands stretched out where open water now sits, and that plain was hunting ground. Deep inside this cave system, researchers found something that stopped the dig in its tracks, a pattern cut directly into the bedrock, not painted, not drawn with charcoal, but carved, a deliberate crosshatch of intersecting lines, pressed into solid limestone with a stone point. When the team dated the surrounding sediment, the layers sealing the engraving in place were older than 39,000 years. That number matters enormously because at that time, and in that specific corner of Europe, there is no evidence modern humans had arrived yet. The only species known to have been living in that cave was Neanderthal. Under magnification, the engraving revealed something even stranger than its age. It wasn't a single motion, a scrape made by accident while butchering an animal or sharpening a tool. Researchers counted the individual grooves and found that producing the design required dozens of separate, deliberate passes with a stone tool, each one following the last with enough precision that the pattern held together as a coherent whole. Experimental archaeologists later tried to recreate it using similar tools and similar rock. It took real effort, real time, and real intention to make lines that clean. This is the detail that undid a century of assumptions. Abstract mark-making, the ability to produce something with no survival function whatsoever, a pattern that exists purely because someone decided it should exist, was supposed to be the line. The line between us and everyone else. The argument went that symbolic thought, the strange human habit of turning raw material into meaning, was the reason we made it, and they didn't. A cross-hatched engraving sitting under 39,000-year-old sediment, made in a part of the cave that natural light barely reaches, quietly erased that argument. Whoever carved those lines worked, at least partially, by feel and memory, or by firelight carried deep into the rock. Either way, they knew what they wanted to make before they started making it. If the engraving suggested Neanderthals could think symbolically, what researchers found in the older layers beneath it suggested something even harder to reconcile with the old picture, that they could do chemistry. At a Neanderthal site further north, in what is now the Netherlands, and independently confirmed at sites across southern Europe, scientists uncovered evidence of a substance called birch bark tar, and at Mediterranean sites, a resin-based version made from rock rose shrub, both used as an adhesive for hafting stone tools onto wooden shafts. Producing tar like this isn't as simple as throwing bark on a campfire. If you heat birch bark in the open air, it just burns to ash. To get usable tar, the material needs to be heated at a controlled temperature in an environment with very little oxygen, a process called pyrolysis. Modern chemists didn't formally describe pyrolysis until relatively recently in scientific history. Neanderthals were doing a version of it, deliberately and repeatedly, tens of thousands of years earlier. Some of the reconstructed hearths associated with this process show real engineering thought. Pits designed to restrict airflow, structured in a way that suggests trial and error refined over time rather than a single lucky accident. That refinement is the important part. A first attempt at any unfamiliar chemical process tends to be crude, a single hole, a single failure mode, low yield. What the evidence shows instead is controlled, repeatable production, consistent enough across multiple separate instances that researchers describe it as evidence of transmitted knowledge. Someone learned how to do this. Someone taught it to someone else. That knowledge moved between individuals and, likely, across generations. The tar itself wasn't decorative. It was structural. It bound stone points to wooden shafts to build composite weapons, tools made of two different manufactured components, engineered to work together as a system. If the adhesive failed, the weapon failed. Building tools this way requires understanding cause and effect over time. This material behaves this way under these conditions, and if I get it wrong, the thing I'm building won't work when I need it to. That is not blind instinct. That is planning. Of everything found at Neanderthal sites across Europe and the Near East, nothing complicates the old, primitive brute narrative quite as thoroughly as how they treated their dead. At Vanguard Cave in northern Iraq, a Neanderthal skeleton, now known to researchers simply by the site's excavation code, was found in a shallow depression cut into the cave floor, body drawn into a position that looked deliberate rather than collapsed. Decades ago, soil samples taken from around the skeleton showed unusually concentrated pollen from several flowering plant species, plants that don't grow inside a dark cave on their own. That finding led to the now famous, if still debated, flower burial hypothesis, the idea that someone gathered blooms from outside and placed them with the body. Later researchers have pushed back on parts of that interpretation, suggesting some of the pollen concentration could be explained by burrowing insects rather than deliberate floral offerings, and that debate is still very much alive in the literature. Science being honest with itself, rather than settling on the version of the story that makes the best documentary, is part of what makes the rest of the evidence so convincing. Because even setting the flower question aside, the body itself tells a clear story. It was positioned with care, in a pit that appears to have been dug rather than simply fallen into. And Shanidar isn't an isolated case. At La Pharisee in France, multiple Neanderthal individuals, including children, were found buried in close proximity within the same rock shelter, in a pattern consistent with a group that understood these individuals belonged together, even in death. At several Neanderthal sites, red ochre, the same iron oxide pigment humans have used for body decoration for tens of thousands of years, turns up in direct association with burials. Coloring a body that can no longer see or feel serves no survival function. It isn't for warmth. It isn't for food. The only plausible explanation left is meaning, some belief, ritual, or emotional framework that made marking the dead worth doing. None of this proves Neanderthals had a concept of an afterlife identical to any modern religious tradition. Archaeologists are careful, and rightly so, not to overclaim. But the pattern across multiple independent sites, deliberate positioning, repeated grouping of related individuals, the use of pigment, points towards something that looks very much like grief with structure. Not just disposal. Ceremony. Here is the part of the story that turns this from ancient history into something closer to autobiography. If you are not of recent sub-Saharan African ancestry, somewhere between 1% and 2% of your genome, on average, traces directly back to Neanderthals. That number comes from comparing modern human genomes to DNA extracted from Neanderthal fossils, most famously from a toe bone found in Siberia's Denisova cave that gave scientists their first high-quality ancient genome back in 2010. The overlap wasn't a fluke or a contamination error. It was confirmation of something researchers had long suspected but couldn't prove. Modern humans and Neanderthals didn't just share the same continent for thousands of years. At various points, in various places, they had children together. That fact alone forces a rereading of the extinction story. This wasn't necessarily a clean replacement, one species marching in and simply outcompeting another into oblivion. In at least some populations, the two groups mixed, intermarried in the loosest biological sense, and the genetic legacy of Neanderthals never actually disappeared. It diluted into the ancestry of nearly everyone alive outside Africa today. Some of that inherited DNA even appears to have been useful, variants linked to immune response and skin pigmentation that may have helped modern humans adapt more quickly to environments Neanderthals had already been living in for hundreds of thousands of years. So the honest answer to what happened to the Neanderthals isn't a single dramatic event. It's a slow, braided ending. Climate change compressed their habitat as ice ages tightened and loosened across tens of thousands of years. Populations that had never been enormous to begin with fragmented further, isolated in shrinking pockets. Modern humans expanded into the same territory, competing for the same resources, and in some cases interbreeding with the very people they were replacing. There's also skeletal evidence at a handful of sites of blunt and sharp force trauma in Neanderthal remains, though whether that reflects violence between species, violence within their own communities, or accidents during hunting is still genuinely debated among researchers, not settled fact. By roughly 40,000 years ago, most of the archaeological signature we associate with Neanderthals fades from the record across most of Europe. Some of the very last populations may have held on longer in refuges like the Iberian Peninsula, the southern edge of the continent, the last strip of coastline before the water. But last is doing a lot of work in that sentence. The dating of final Neanderthal presence is one of the more contested corners of the field, and estimates have shifted more than once as new techniques improve. Strip away the sensational framing you'll find in a lot of online retellings of this material, and what's left is still remarkable enough to need no exaggeration. A species we spent a century describing as barely capable of thought was carving deliberate abstract patterns into cave walls by firelight. They were running controlled chemical processes to manufacture adhesive, refining the method across generations. They were at multiple sites, treating their dead with a level of care that looks a great deal like grief. And when modern humans finally met them face to face, the two populations didn't just coexist. In some places, in some moments, they became family, closely enough that the genetic evidence is written into the DNA of billions of people alive right now. The old story was simple because simple stories are comfortable. We were the clever ones. They were the ones who couldn't keep up. It let modern humans stand at the end of the timeline and feel like the inevitable, deserving result of it. The evidence coming out of caves like the ones on Gibraltar tells a messier more. Honest story. Neanderthals weren't a failed draft of us. They were a different, fully realized way of being human with their own tools, their own art, their own rituals for the dead, built and refined over a span of time roughly 6 times longer than the entire history of anatomically modern humans on Earth. What ended wasn't an inferior species finally losing a fair fight. What ended was one branch of a family, absorbed in part into the other, its distinct culture and knowledge fading out even as fragments of its biology quietly persisted. Every layer of sediment archaeologists remove in these caves adds a little more nuance, corrects a little more of the old caricature, and complicates the tidy narrative a bit further. That's not a weakness in the science. That's what real science looks like, a story that keeps getting rewritten because we keep being willing to listen to what the evidence actually says, instead of the version we'd prefer to hear. They didn't vanish. They were never as simple as we needed them to be. And in a very real, measurable sense, written into the genome of most people reading this, they're still here.